Okay, so in this example, they tell us that a gas is contained in a cylinder fitted with a movable piston. Okay, there's a clamp that's holding the cylinder in place. The initial temperature is 25 degrees Celsius, and the cylinder is being placed in boiling water where it's heated, but it's held in a fixed position. A heat of 2 kilocalories is transferred to the system, and it reaches 100 degrees Celsius. And thereafter, the clamp is released, and then the cylinder does work. Okay. They want us to write out the energy balances and solve for these for this process. And we're given a hint that it occurs in two parts. So what we will do is we will first look at the heating phase of the piston where the clamp is still on, and we'll conduct an energy balance for that, and then we will look at the point when the clamp is removed and the cylinder does work. Okay, so for the first part, which is called A, we have the cylinder with the clamp. It's heated from 25 degrees Celsius to 100 degrees Celsius. All right. We can see that this is a closed system because there's no transfer of mass. So if we write out our energy balance, we're not going to look at enthalpies. We'll use internal energy. Then we have changes in kinetic energy, in potential energy, and that must give us the changes in heat transfer and work. So for the first part of the question, before the clamp is removed, there is no work being done by the piston because it does not change, and there is no kinetic energy changes, and they tell us that we can ignore the potential energy changes. So all we have is that the internal energy change is equal to the heat transferred, and that is very simple to solve. That's 2 kilocalories as given to us, and if we convert that to joules, we will get 8,370 joules. Okay, so that's the energy balance for the first part of the process. Now we are at, the piston is at 100 degrees Celsius, the clamp is on, and then the clamp is released, and so the piston expands. It's still at 100 degrees Celsius, but of course it now has done some work. So for an ideal gas, which is what they told us is in the piston, the change of internal energy is zero when the change in temperature is zero. Okay, so our energy balance reduces to 0 is equal to Q plus W. Of course, again, there's no kinetic or potential energy changes. The work is given as, they tell us that it's 100 joules of work, but this work is leaving the system, so that is equal to minus 100 joules that the system is doing. So if we go back to our energy balance, we're going to have 0 is equal to Q minus 100 joules. So Q is equal to 100 joules. So what does this mean? This means that as the piston expands, heat is transferred into the piston in order for this expansion to occur.